In this video, we're going to derive one of many divisibility rules for 13. First thing we need to note is if k is any positive integer, then k can be written as an integer multiple of k plus a digit. So let's state that. Where a is a non-negative integer and b is a digit. And if you don't believe that's true, let's just look at a fairly big number. This number is 10 times 7234, and then add 5. And if you don't believe that, 10 times that number is that number with the 0. When we add on 5, we do get 72345, which is that number. So it's 10 times a plus b, 10a plus b. Well, what if we had a smaller number, like 75? Well, this is 10 times 7, which is 70, plus 5. And 70 plus 5, that's 75. Well, what if we had a single-digit number? Well, that would be, so let's go back to the last one. It's 10 times a plus b. Okay, a happens to be a digit, but all we promised is that a will be a non-negative integer, and a single positive digit is our non-negative integer. I guess all digits are positive. 3 is 10 times 0 plus 3. That, of course, is 10. That's my a. It's a non-negative integer plus b, a digit. So large numbers, two-digit numbers, single-digit numbers, it works for. Okay. So here's the proof. 13 divides k if and only if 13 divides k, which is 10a plus b. Nobody can argue that. If and only if 13 divides any other way of writing that. Well, I choose to write it as 10a plus b. Now, I'd really like to have a multiple of 13 here. So I'm going to add 3a. So before I forget, I better take away 3a. Why did I add 3a? Because 10a plus 3a is 13a. And when it comes to the plus b, plus 1b, I'm going to add 12b. So now this plus that is 13b. Well, I better take away the 12b. What's in green is really 0. Okay. So if and only if 13 divides this mess, because that mess is just 10a plus b. Well, I'm going to add the 10a into 3a. That gives me 13a. I'm going to add the b and the 12b. That gives me 13b. I'm going to be able to factor out a 13. And then let's not forget to take away 3a and take away 12b. Okay, 13 divides that. If and only if 13 divides another way of writing that. Well, I want to write that as 13 times a plus b minus, I can factor out as 3a, and I get, I can factor out a negative 3, and then I get a plus 4b. Okay, now clearly 13 goes into this. because you can see it. It equals that integer. 13 went into that. So the only way 13 is going to go into the difference is if and only if 13 goes into what we're subtracting. If and only if 13 goes into 3 times a plus 4b. So now we want to do 13 into 3 times a plus 4b. Now, I just want to change the numbers for a moment. If it was a 5 instead of a 3 on the top, and maybe a 15 instead of 13 on the bottom, yes, this 5 can help the reducing. For example, 5 goes into both of those numbers 1 time and 3 times. And 1 times that is just a plus b, and the bottom is 3. So if in fact we had 5 times a plus b over 15, then 3 must go into a plus b. That's for sure. But in our case, you can't reduce the 13 into 3 at all. That is, if 13 is going to divide into the numerator, then 13 has to go into the a plus 4b. That is, if and only if 13 goes into a plus 4b. And remember, the a and the b came from k being 10a plus b. Okay, so here's the rule. 13 must go into a plus 4b. And that's the end of the theorem. We derived the divisibility rule for 13 is a plus 4b. Just for the record, if 13 divides a plus 4b, then it would also divide a plus 4b minus 13b, because that's a multiple of 13. That means 13 will divide a minus 9b. That's another rule. That's yet another rule. So the rule isn't unique. This is one of them. And let us just show how it works. Let's look at a multiple of 13. 3 times 24, I happen to know that's 72. And 1 times 24 is 24. So 312, if I did my multiplication correctly, is a multiple of 13. So a plus 4b. So this becomes a and b. So I take a, 31, and I add 4 b's. 4 2's is 8, 39. Does 13 go in there? Well, you probably should know that 13 times 3 is 39. Okay. Now, if you didn't, you're kind of in trouble, because now I take a and I add 4b, which is 36. And I was going to say we're going to get a pretty big number again anyways, but we actually got the same number. So, if it comes down to it, you can verify. 13, it looks around 3, and yeah, 13 times 3 is 39. You subtract, you get 0. Okay, so 13 goes into all the numbers we came up with. 13 goes into 312, 13 goes into 39, and since we didn't like 39, we tried again, and again we got 39. Okay, so this is how it works. Now, if I randomly pick a number, 2, 4, 5, I'm hoping that's not a multiple of 13, but basically you take that number and you add on 4 times that, which is 20, and you get 44. And if you know your 13 table, the answer is no. If you don't know your 13 table, you take the 4 and then you add on 4 times 4, which is 16, and you get 20. And you really should know 13 isn't 20, and 13 plus 20, that is 13 times 2, is more than 20. But if you insist, you can take the 2 and then add on 4 times 0, which is 2, and that's not a multiple of 7. So doing as many steps as we could. I have the first number. I did this process once. I did it a second time, and I did it a third time. The second time really should be sufficient. 13, 26, 39. This is just a few more, 5 more. The next number here will be 13 more. Went right past 45. So one step wouldn't have been bad. The second step you should know. Even if you don't know what 13 plus 13 is. You know 10 plus 10 is 20. If you put in $10 in the bank today and tomorrow, you put in a total of 20. If I put in 13 and 13 today and tomorrow, I'm going to have more than 20. Okay, so 13 doesn't go in there. If you like theorems like this, videos like this, please subscribe to my channel. Tell your family and friends about this channel. Let's make this channel a success. I was told that this channel helps the mathematical community, which is excellent to be told. Most of all, as always, watch and learn.